So we're moving into what I think is really one of the most critical discussions in the CCIE track, especially for the written exam. The lab exam, there are definitely some things that we're going to discuss in tonight's lesson that are going to be related to the lab exam. And this is a little bit of an extension about what we talked about in the last lesson, but we've pretty much been focusing on single area configuration in this particular case. And now what we're going to be doing in our topology is we're going to be looking at multi-area configuration. It's similar and pretty much the same topology that we had the last time. For some reason it wouldn't load up, so I had to kind of grab another file. But same topology that we used the last time when we were kind of troubleshooting different adjacencies and looking at some of the issues that might come up in the process of configuring OSPF. But in our lesson this time, our focus is going to be on Lsa types. And I'm going to demonstrate all of the Lsa types that you would see in IPv4. And we're going to talk about each Lsa type, what the purpose of that Lsa type is. We're going to take a look at database information, what kind of information is contained in those LSAs, and why those particular LSAs are important. Now later on, we are going to be talking about special area types like stub areas, configuring stub areas, not so stubby areas, redistribution, which is going to end up generating several other types of routes in our topology. So we won't spend as much time on the Lsa types that you would see in those particular topologies, but we're definitely going to spend some time talking about the different Lsa types. We already talked about type 1 and type 2. We'll revisit those as part of our overall review in this particular lesson. And then we're going to talk about type 3 LSAs. We'll talk about type 4s, type 5s. We're going to have to trick our network into generating those LSAs. And then I'm going to configure some special area types, and we'll take a look at what type 7s are and so on. So we're going to talk about in this lesson type 1 LSAs, type 2 LSAs, type 3s, type 4s, type 5s, and type 7s. Those are all of the primary Lsa types that we're going to see in a v4 OSPF network. There are some other LSAs that go beyond that, 8 and 9, for example, and some LSAs that are used for IPv6, but we'll get into that discussion when we get into setting up OSPF v3. And let me see, do we have a specific lesson for OSPF v3? If not, I'm going to add that. I don't see a specific lesson identified for OSPF v3, but that's essentially OSPF for address families or OSPF with IPv6. So when it comes to troubleshooting and configuration, you can't really, there's not a whole lot you can do to control the Lsa types that are going to show up in your topology because they're automatically generated based on the types of routers that you have in the topology. And I'm going to use this diagram as I go through a description of each of these Lsa types to kind of give you an idea of where these LSAs might be generated from, number one. And number two, let me put this in Paint because I want to use my text tool here. Number two, what is the scope of those LSAs? Where will we see them? Are they intra-area? Are they inter-area? What do they describe? And so on. You guys have been through the CCNP class, so you have learned this stuff from before, but obviously this is going to be an important review topic. And if you haven't gone through the CCNP in a while, most likely you don't remember a lot of these details, okay? So let's start with type 1 LSAs. And I'm going to try and just keep a little summary over here. Type 1 LSAs, and I'll save this diagram once we're done with our discussion. Type 1 LSAs, those are called router LSAs. Where'd my mouse go? Back to my mouse go. Mousy, where'd you go? There you go. All right. Those are called router LSAs. And if you recall, these are generated by all routers in OSPF. I'm not going to put all the details here. I'm just going to put some of the highlights. They're generated by all routers in the OSPF topology. And their scope is intra-area. All right? And they also show up in the routing table as what we call O routes. All right, so those are our type 1 LSAs. They're generated by, I want to make sure I have enough space to put all these guys in here. So they're generated by all routers in OSPF. So we're going to see, for example, type 1 LSAs generated by router 4 and router 2 and so on. But once they hit this ABR, those LSAs no longer remain as type 1s. They actually become type 3s. I'm going to get into that in a little bit because in the last lesson we really focused primarily on single area OSPF. Okay? So LSA type 1 LSAs, these are known as router LSAs. Every single router participating in OSPF is going to generate one of these LSA types, and they actually get flooded within the area that the router belongs to. All right? So what is it that a type 1 LSA is going to tell us? Number one, it's going to tell us whether or not this is an area border router or whether or not this is an ASBR. Let me show you what that looks like. If I go into router 1, for example, and I do a show IP OSPF database, I can see the router link states listed here. And if I drill into what's coming from, say, router 1, I can see the capabilities of this particular platform. We see all of the different LSAs and some of the options that are advertised, but these are the LSAs that are being advertised by router 1 in area 0. And if I look at router 1 is an ABR. So one of the things that I would be able to identify based on these LSAs that are being generated is whether or not this router is an ABR, number one, and we can see that listed here. It is an area border router for this particular area. It has 2 links in area 1. This is the link state ID, which is the router ID of the advertising router. And then this is the advertising router information, which is also the router ID of the advertising router. And then I see the age of the link state advertisements. Now, I don't remember if I actually told you about that last time. I think we kind of gleaned over it or maybe glanced over it a little bit. But the age of the LSAs are going to indicate in the database how many times we've received an update for that particular LSA. And the number actually starts at a 1. In fact, if I do a show IP OSPF database, I might even see, database. Yeah, I can see 1 here. I've got an LSA that I received from router 1.1.1. This is a netlink state LSA, so it's a type 2 LSA. And it has a sequence number of 800000001. That indicates that that's the only advertisement I've received about that. That's the only type 2 LSA I've received from that particular advertising router related to that particular link. If I was to flush out OSPF, let's go ahead and do a clear IP OSPF process. And I wait for my adjacencies to reset. Show IP OSPF database, you can see that a lot of these LSAs are going to reset to 1 because we've basically reset the process. Now, this would be on router 1 because router 1 is the router that I reset the process on, but you can see it also incremented the age or the sequence number for the type 1 LSAs that are being advertised by router 4. And that's because router 4 is keeping track of the sequences that were sent as the adjacency came up between router 4 and router 1. So every single time I reset router 1's OSPF process, you'll see that that age will increment by another value. Excuse me. All right, so if I go back to my database, I can see that, well, it didn't go up to 4. That's interesting. We could clear the process on router 4, and that would cause that to increment. But anyway, the age or the sequence number is going to allow me to identify, essentially, is this the latest information? So let's say that I'm on sequence number 1, and I receive a link state advertisement from a peer, and that sequence number is 3 or 4 or 5 or whatever it might be. It's highly unlikely that that would happen because usually we're synchronizing the database anyway. But that means that would tell me as a receiving router that the information that I just received is newer than what I have in my current database. And in that particular case, that means that I'm going to go ahead and update my information with that latest information that I received from that peer. Okay? So eventually what would happen, and we could go through this and compare this to all the other platforms, we would all eventually have the same sequence number because we've all synchronized. The maximum value that that will go to is actually, it's kind of weird, is hex 7 FF, 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 FF. It's supposed to be specifically a range. And if you go to RFC 2328, you can actually read the details about how the sequence numbers were selected. It identifies the age of the LSA. All right. We don't need to get into the specific details about the age of the LSA. It's not really that important. You're not going to be tested on that. You just need to be aware that the higher the sequence number, the more up-to-date that information is, potentially. And it also indicates that we've actually started to receive updates about that particular database entry. Okay? So what are some of the other types of things? Yes?
So you keep mentioning age, but age is like, you're talking about sequence number, but there's actually age next to it. What's the difference between those two?
Okay. Yeah, you're right. I probably shouldn't use the term age because age indicates how long the information has been in my database. So maybe I should refer to the sequence number as kind of like a revision, if you will. Okay. Age is different in that we maintain information in OSPF for a certain period of time. One of the things that we talked about with regard to OSPF the last time we spoke was something called a paranoid update. After 30 minutes, and these age timers are in increments of seconds, after 30 minutes, the router that originated any entry is going to flood out the LSA with another sequence number than the one that it had previously. So the age is kind of like an incremental timer that allows me to identify the age of the LSA within the database. And the age will always reset after a certain amount of time. If I don't get an update about an LSA for the max age timer, the max age timer is 60 minutes. So every 30 minutes, I should be resynchronizing my database. And if I was to wait, so let's say, what is 30 minutes? 3,600 seconds, I think. Is that right? You guys help me with the math on that. But I think it's 3,600 seconds. So as I'm watching this database time go up, you'll see that the time is incrementing. And eventually, once this reaches 30 minutes, I should see the sequence number increment because that from that particular peer, because that LSA is being flooded again with a higher sequence number. And it's just, we call it a paranoid update in OSPF. It's just to enforce the idea that the databases need to remain synchronized, okay? And so age is like that timer that allows me to identify whether or not entries in the database have become stale. you know, meaning that they have that max age timer of 60 minutes and so on, or 60 minutes. So our paranoid update timer is 30 minutes, but every 60 minutes, if I don't receive that paranoid update within that 30-minute window, which essentially verifies that the link is still active and the information is still accurate, if I reach that maximum age timer of 60 minutes, I'm going to discard that entry from my database, essentially. Okay? So it's possible, Tim, that I might not, maybe somebody sends out, and it's not likely because we do acknowledge link state updates and link state advertisements, but let's say, for example, that somehow I missed one of those updates, and then later on I received another update before the 60-minute window expired. That next update will most likely have a higher sequence number than the sequence number that I have in my database. So I will essentially flush out the information that I had. Maybe it's a 3, and I'll put in sequence number 4. Did that answer your question? I hope it helped. I didn't really explain it very well, but okay. All right. We always talk about OSPF as being kind of an incremental protocol, and it updates everything, all the information incrementally. But the reality is that it does periodic updates as well with that paranoid update. Okay. So there are some values that you will see in these outputs here. Let me see if I can show you another one. Show IP, OSPF, database, self-originate. So these are all of the LSAs that I'm originating from my router. Self-originate allows me to identify what I'm advertising to my peers. You can see obviously the advertising router is 1.1.1.1 in every case here, and it indicates the link information that I'm advertising. So we had talked about router link states in our first lesson. Those are my type 1 LSAs. Summary net link states are my type 3 LSAs. So that's going to be interesting. We'll get into that later on in this lesson and kind of learn about what is a summary LSA. Why do my summary LSAs pretty much look like my type 1 LSAs? So some of the other things, is it if there's an EBIT set, for example. I'm trying to remember. Let me see. Show IP, OSPF, database. I think I could just do it for, let's see if I can, let's do router 4.4.4.4. We might have to configure some additional properties on these routers. Yeah, so this one is an autonomous system boundary router. If I was, so this guy's redistributing routes into OSPF from the internet, which makes it an ASBR. If I was to come into this link here and start doing a packet capture, what I'm going to see in the hello packets are various bits that are set to indicate what type of router this is. Okay? Now you can actually see that in the type 1 LSAs as well. When the LSAs are being advertised, I would have to restart the OSPF process to generate those, or wait my 30 minutes to generate the LSAs. But we should also see it in the hello packet. There's an EBIT that gets set. It's just a flag field that gets set in the advertisements that represents that router as an area border router or an autonomous system boundary router. And I want to see if I can actually see that. Let me check the IP address, router 4, show IP protocols. So 4.4.4.4, show IP interface brief. So these guys should be coming from 14.2, all right? So if I go into my hello packet for 14.2, one of the things that I should see, right, is this EBIT set, okay? We would also see that in the link state advertisement, specifically the type 1 LSAs, all right? And let's see if we see that down here. We may see it down here, but we also, yeah, we'd probably have to do a a reset of the OSPF process. But this E bit indicates, which is right here, this E bit indicates that this router is an autonomous system boundary router. Okay? An autonomous system boundary router, and we'll get into this later because we're going to start to look at other LSA types, but an autonomous system boundary router is any router in OSPF that takes routes from another routing process and sends them into OSPF through redistribution. Okay? Those types of routers, those routers are going to be generating a very specific type of route. And I don't want to overwhelm the discussion just yet by going into all the details. I kind of want to progress through each of the types so that we're not jumping back and forth, because it can get really confusing when you start moving back and forth. But because the type 1 LSAs include that bit, I wanted to describe what that bit was. There's also something called a B bit, the Bravo bit. That indicates that it is a autonomous system boundary router. Or a ABR. Okay, so we'll talk about that. We'll see that a little bit later on as well. Actually, I could have left open my Wireshark here, but again, if I was to capture on this line, I should see from router 1. Let me show you, because I want you guys to see this in one of the things that they might have you do. Most of the stuff that we're going to be talking about today, and it's going to be kind of a longer lesson, but most of the stuff that we're going to be talking about today is primarily going to be related to the stuff that you might need to know for the written exam. I doubt that they would have you, do some level of troubleshooting or functional troubleshooting on the CCIE lab, where you're actually having to drill down into packet captures and not sure why it's not opening, but packet captures, and you're trying to look at different bits or different values that are included in those captures to be able to troubleshoot or determine what's happening. It's mostly about just understanding what's being advertised, why it's being advertised, what is this bit, why does this bit have to be set, what does it represent. There's also a V bit, which we would set if the router is terminating a virtual link. And it's advertising prefixes or reachability information over a virtual link. So type 1 LSAs do include a lot of different pieces. The number of links, the link types, is it a point-to-point link? Is it a virtual link? Is it a transit network? Is it a stub network? What is the link cost? What is the link metric? And so on. I don't know why my capture's not going. I think I got it hung up there. That's okay. All right. So let's talk about the type 1 LSAs from the perspective of router 4. All right. Now you could go into router 4 and just simply say show IP OSPF database. But we're interested in specifically seeing the router link states. One of the things that you might be helpful in when you're doing your troubleshooting section on the test is to do show IP OSPF router self-originate, or a show IP OSPF database self-originate. And you should be able to see, yep, exactly, the type 1 LSAs that are being generated by this router. I can tell, because I use the self-originate command, that this router is generating type 1 LSAs, it's generating type 2 LSAs, which are my netlink state LSAs, and it's generating type 5 LSAs, which we're going to talk about a little bit later on, which are what we call external LSAs. These are the LSAs that represent the routes that are coming from an external domain. So because router 4 is redistributing routes from the internet, it's generating these type 5 LSAs into the domain. All right? There's a lot of good information in LSA type 1. You kind of think of this as like the blueprint of the router. Basically, this is what the router has, this is what the router's doing, this is what it's advertising in the topology. So I can drill down into these LSAs, show IP OSPF database router, and I can see specifically what it is that's being advertised. The routing bit set, this LSA age is 681, again indicating the overall age in seconds. That's over time, how old that LSA has become. The link state type, these are my router links, which are type 2. The link state ID in this case, so this is a type 1 LSA that's coming from router 1 in area 0. The sequence number, I've received 3 different updates from this particular, or 3 different link state updates, including this advertisement. The checksum allows me to verify the integrity, of course, of the LSA using a standard hashing process. 48 bytes. This is an area border router. It has 2 links that it's advertising. One is a stub network, which you'd find in this case is the loopback interface on router 1, which is in area 0. It has a metric of 1, which does define the cost. The metric does define the cost of the loopback interface. Now, we haven't had a chance to really talk about the metric, but we are going to get into metrics when we get into the traffic engineering section for OSPF. We want to do route manipulation and path selection manipulation and so on. And we'll talk about the metric. But the overall calculation for OSPF is 10 to the power of 8 divided by the link bandwidth in bits per second. The problem is that reference bandwidth of 10 to the power of 8 is essentially fast Ethernet. So anything that's going to have fast Ethernet or above is going to end up having the same overall cost, path cost. All right? So we will spend some time talking about that. How can we change that numerator so that our paths don't always look like the same? I don't want my fast Ethernet links and my gig links and my terabit links and so on to look the same. So I definitely want to maybe manipulate that reference bandwidth, and we do that with auto cost reference bandwidth in OSPF to do that. So we're seeing the metric of the link. This is the transit link. Because it's a transit network, that means there's a DR-BDR election. So we're going to see the DR and the BDR for that transit link. This is the cost of that link. In this case, it happens to be Ethernet. So those are the 2 links that I'm receiving from router number 1. And then I also see the links that I'm responsible for. Okay, so this is the loop back on router 4. This is the transit network on router 4. And of course, everybody's going to agree with that. Okay. Now, what's interesting about this is to define the scope here. My type 1 LSAs, which are intra-area LSAs. So if I go to my router 4 and I do a show IP route OSPF, and section O, these routes here, that route there is my type 1 route. I know it's a type 1 route because it's simply just got an O next to it, right? Which indicates that that is a intra-area route. Conversely, these routes here that have an OIA next to them, those are the routes that are coming from another area. So those are what we call our summary routes. They're not summarized by default. We'll talk about that today as well. But they represent type 1s. So there's a relationship between my type 1s and my type 3s. Let me go back to my diagram here. All right. So if I've got, let's say, this loop back right here on router 4. Let me change my pin to red here. That's being advertised as a type 1 LSA to the other routers within the area. Once the type 1 crosses an area border router, which is what R1 is, those type 1s become type 3s. So I should see in area 2 and area 1, the 192.168.4.0 network showing up in router 2 and router 3 as an OIA route, and I should see that in the database in router 2 and router 4 as a summary LSA. So let's go to router 2 and just verify that we're receiving that. Show IP OSPF database. And I'll do summary to look at my summary routes. And sure enough, here is the 14 subnet. The advertising router is the ABR. and this represents a /25 prefix. Let me make sure I'm looking at the right subnet here. I believe I am. Yep, 14/25. So when a type 1 LSA crosses an area border router, it becomes a type 3. I'm going to talk about type 3s in a second in more detail. These are called summary LSAs for a reason, but they're not actually summaries by default. If I had 1,000 type 1 LSAs in area 0, they would become 1,000 type 1 LSAs in these areas as well. OSPF does not summarize by default into other areas. So essentially all of my type 1 LSAs will become type 3 LSAs, and it'll happen in both directions. So this loop back here will become a type 3 in this area, this loop back here will become a type 3 in this area, and so on. Okay? We'll drill down into the type 3 in more detail, but when we get to type 3, and I'm going to keep my notes on the slide here for each of the LSA types. All right? So type 1s are relatively simple. They're pretty easy to understand. Type 1s should only be common within the area because they never cross the area border router. Type 2 LSAs, all right? Type 2 LSAs, change my color back. Type 2 LSAs, these are called network LSAs, and they are generated by designated routers in the OSPF topology. The scope of these type 2 LSAs is intra-area, and they don't actually show up in the routing table as a route. Because if you recall from our discussion, type 2 LSAs don't actually describe prefixes, they describe multi-access networks. So if I was to go into router number 1 and I do a show IP OSPF database, you can see the net link states, what we call network LSAs. I guess I should have typed it out as net link state, but if I do a show IP OSPF database net, I will see the details. That's why I called it a network LSA, because technically it's called a network LSA. I will see the details of what these type 2 LSAs represent. All right, so we got our age here. Again, that's just going to continue to increment. We have this router is generating well, this is the router ID of my local router, but actually I'm not generating the type 2 LSA. Router 4 is the advertising router of the type 2 LSA. Network LSAs are generated, like I said, by the designated router. And we're going to see one type 2 LSA for every network that has neighbor relationships in a multi-access domain. So we would expect to find these when we have like multiple devices connected to a switch, or maybe it's a frame relay type network or a DMVPN type network, and so on. But you can see from the output here, the type 2 LSA is going to include information about all of the routers that are attached to that multi-access segment. And it's just really an informative LSA. It essentially lets us know, or lets the other routers within the area know, that either you're connected to a multi-access network with a bunch of other peers, or here is information about the multi-access network. And by the way, these are all the peers that are connected to that multi-access network. So it doesn't actually describe routes, it simply describes the multi-access network. This is the sequence number, checksum of course. This is the subnet mask of the transit network. And then these are the routers that are presently attached to that transit network. Now you can do your Boolean math and you can infer what the network ID is for that prefix or for that network by anding your address and your subnet mask together to calculate the network ID for that particular for that particular transit network. 14.2, in this case, the link state ID, and that's the kind of stuff they might ask you on the written exam. You know, which address below would represent the link state ID of a Type 2 LSA? Be a challenging question, but the reality is it's the physical IP address of the interface that's participating in the multi-access network. So 14.2 is the physical IP it happens to be of the designated router in this case, which makes sense because the DR is the one that's generating that LSA. And it's the physical address of that interface that's participating in that domain. The advertising router is the router ID of router 4. So I can tell that in this network here, in area 0, router 4 is the DR for a multi-access network. In area 1, router 2 is the DR. And in area 2, router 3 is the DR. Okay? So again, more of an informative LSA, intra area, meaning that it does not propagate beyond the area. So let me go ahead and I guess I'm okay. I don't really need to put any more details for the type 2, unless you guys have any other questions. A Type 3 LSA is referred to as a Summary Lsa, and it's called a Summary Lsa for a specific reason, because it's supposed to represent a summary network for all of the Type 1 LSAs that are originating from a particular domain. So this is going to be generated by an ABR, Area Border Router. Essentially, well, I guess it depends on the perspective of whether it's the network or the router, but we're generating these Type 3 LSAs across into other areas that represent the Type 1 LSAs that are coming from an area. So let me see how I want to say that. Generated by an ABR, and they represent and I'll put it in quotes here, a summary of all of the Type 1 LSAs on the ingress to the ABR from an area. I'm trying to think about if there's a better way to say that, but I think you guys understand what I'm trying to say here. So if I've got a bunch of Type 1 LSAs in area 0, those LSAs are going to be represented as Type 3 LSAs when they move into area 2 and area 3. One thing I will say, though, is that summary LSAs, summarization does not happen automatically. So let me see if I can go into router 2 and maybe throw in a couple more loopbacks here. Let's do, so I can kind of show you what I mean here. Show IP interface brief. So let me do 3 different loopbacks. Interface loopback 1, we'll give that an IP address of 10.10.10. Now let's do 8. .1, 255.255.255.0. I'm also going to change the OSPF network type to point-to-point, just so that it doesn't look like a loopback to the rest of the world. Interface loopback 2. And let's go ahead and make this 9.1. Same thing, point-to-point. Interface loopback 3, we'll make this 10.1. And point-to-point on that one as well. All right, so if I do a show IP OSPF database router, I should see now, let's just do the summary. I should see that router 2 should have, interface loopback, do show IP protocols. I forgot to turn it on. Interface loopback 1, IP OSPF 1 area 1. Make sure I got the right area here. Area 1, yep. I've got to enable OSPF on the interfaces, so otherwise it's not going to be advertised at all. Interface loopback 2. And by the way, I saw that, I should have known that from the beginning, but I saw that because my link count didn't go up. When I was looking at the router link states, I should see this link count go up because I'm adding additional type 1 LSAs to the process. So interface loopback 3. And now if I do a show IP OSPF database, I should see that link count go up, which indicates that those links are now participating in OSPF. Okay? So those are type 1s in area 1, but now if I go to router 4, show IP route, you will see that those loopbacks are showing up on router 4 as OIA routes, but they're showing up individually, meaning that summarization did not occur automatically. They just simply showed up as their individual subnets. And if I do a show IP OSPF database summary, I can see, let's do router 1. Well, that's the only place they would come from anyway, is router 1. So let's just do our summary. So I should be able to see those prefixes coming in. There's the .9 summary network. So this is a type 3 LSA, has a metric of 11. There's my .10, and of course my .8 is going to be up here. So we're seeing the prefix for the loopbacks here because I changed the network type. We're seeing the network ID. I'm seeing the cost, and I'm also seeing who's responsible for originating these particular routes. And in this case, router 1, which is the ABR, is responsible for originating these types of routes. So we need to make sure that we plan out our topology in a way that we can actually take those loopbacks that I've added to this network over here, 10.10.10 or 8.0/24, 10.10.9.0/24, and 10.10.10.0/24. And I want to be able to summarize these routes. Now we are going to do a couple of lessons on summarization, but I'm going to show you, doesn't hurt to see it more than once, how we would summarize those routes. In EIGRP, we could summarize anywhere we wanted to in the topology because the summaries would take place on the physical interface. In OSPF, there's only two types of routers that you can summarize on. One is a ABR, and the other one is an autonomous system boundary router. So I'm only allowed to summarize on router 1 for these 3 loopback interfaces. I'm going to do this quickly because we're going to see a lesson on summaries a little bit later on, but I want to show you how it affects the routes that are going to show up on router 4. So I'm going to go into my OSPF process, router OSPF 1, and I'm going to do the area range command, area range. Why isn't it letting me? Area, what the heck? Oh, sorry. You got to specify the area first, then you use the range command. So this is a really important point. And again, we'll talk about this in a little bit more detail when we get into the summary. Whenever you're doing summaries in OSPF, it's different than when you're doing summaries in EIGRP. In EIGRP, you apply the summary on the egress interface that you want the summary to originate from. So if this was EIGRP, I would probably most likely just summarize on this interface right here in this direction using the summary address command. Even if I chose in EIGRP to summarize on the area border router, if this was EIGRP, not called an area border router, and we wouldn't have multiple areas, but I would still be summarizing on the egress interface towards router 4 because that's where summaries get applied in EIGRP. In the case of OSPF, we use the area range command to identify a summary, but we have to specify the area that we're summarizing from, not the area that we're summarizing to. So when I go into my command, area 1 range, for some reason I was thinking area range 1. I had that stuck in my head. Area 1 range means that I'm going to summarize from this area, and then automatically I will start to generate those summary type 3 LSAs into the other areas. So I don't really have to worry about applying the summary in multiple locations. It's automatically going to apply that summary in all the other areas that the router is participating in. So let me go back to my router here, and I'm going to say area 1 range, and we're just going to do 10.10.8.0, and then we can specify the mask for the summary. We'll just do a block of 4 in this case, so that's going to include 8, 9, 10, and 11, and that's it. So now if I do a show IP OSPF database self-originate, I can see that the summary netlink states are being advertised, and this one right here indicates because the age is 6, obviously that's the one I just created, indicates the summary that I just started advertising. Okay, so if I go to router 4 now, and I look at, oh come on, I think I just put that there. Yeah, okay. If I go to router 4 now and I do a show IP route OSPF, now I'm getting the summary route as opposed to, it's a /22, as opposed to the 3 routes, but it still shows up as an OIA route, and it still has cumulative metrics and path cost metrics, just like the individual routes would. So the summary doesn't really change as far as its representation on the other routers that are receiving the Type 3 LSA. But again, the most important thing to understand is that these summaries are not going to be created automatically on the area border router. You have to manually configure the summaries for each of the prefixes that you want to summarize to the other areas. And we'll talk about traffic engineering and how we can manipulate the summaries that are being sent from one area to another. I don't want to get into that in too much detail right now, because we'll be getting into that in more detail when we go into those sections, okay? So a Type 3, just to summarize here, pun intended, a summary LSA is generated by the area border router. It's used essentially to extend reachability to other areas. Remember, Type 1 LSAs, they're not going to get propagated from one area to the other. All right, they're limited to the area that they were originated in. So this is something that allows those routes to be reachable from other areas. We call these inter-area connectivity as opposed to intra-area, because these are LSAs that would propagate throughout the autonomous system. Okay? A good rule of thumb by default is that for every route in the routing table, there should be some sort of Type 3 LSA in the link state database, unless you're summarizing, right? So if I go into router 4 and I say show IP OSPF database summary, you can see in this case, well, let's do this. Let's just look at the quick list here. I can see the summary netlink states here. I'm not seeing the 9 and the 10 anymore individually. I'm only seeing the 10.10.8.0. So what I mean to say by you should at least see, well, I wouldn't even say that. I would say by default, if you're not summarizing, you should see a Type 3 LSA for every single Type 1 LSA that exists in other areas. Okay? So far, so good? You guys doing okay?
Scott, for the Type 1 LSAs for the loopback, how come we don't see that in the router link state 0? Database?
Which ones are you referring to?
Under router link states area 0?
Yes, sir.
So this is router 4, but router 1 is where we were advertising. So if we go to router 1,
Yep.
do we see them?
Which?
I'm confused. What am I not seeing? I'm only seeing summaries. How come I'm not seeing since?
Oh, because I did self-originate.
Oh, okay.
Yeah, this was a self, yeah, so if I did a show IP OSPF database here, you're going to see the same database that router 4 has. Remember, within the area, every router is going to have the same database eventually. And if
So,
go ahead.
so the loopbacks don't actually show up?
They do. They do.
On that, I don't understand, like, why isn't it showing up as an LSA1?
It is. The loopbacks you're talking about for router 1, but you have to consider each area. So these are the router link states that I'm learning from area 0. These are the router link states that I'm learning from area 1, and they're right here, right? Those you're talking about the loopbacks that I created, right?
Right.
Yeah, they're there, right? This is just a summary of the database. So I would have to do show IP OSPF database router, and then I would see those individual LSAs coming from router 2, which is right here. And here is the 8, here is the 9, here is the 10. Does that make sense?
Got it. So there's no any summary or anything that you have to...
Well, the only thing you can kind of infer from the database, show IP OSPF database, is that you can at least see that you're getting 5 links. You don't know what they are, but you know there's 5 links that you're learning about from router 2, and you could kind of match that up to the diagram if you wanted to. If you wanted to say, well, I have 5 interfaces, so I should have 5 links. See what I'm saying?
I get it. Yep, thanks.
Yep. Wow, he sounds a little upset right now.
Yeah, he's not a happy camper.
Not a...
Put bamboo shoots in the house.
Yes, yes. Well, that's the joys of being a father. Yep. So I did forget to write one thing here. I didn't write the scope. So let me add that real quick. The scope of a type 3 LSA is inter-area. All right, meaning that type 3 LSAs move, well, it's kind of weird with a type 3 LSA, right? Because they're not really technically inter-area. They're defined as inter-area because they are generated by the ABR into an area, but it's not like router 2, for example, is generating type 3 LSAs, and then somehow those are being moved over here. So we do define them as inter-area, which means they are link state advertisements that represent prefixes in another area. That makes them inter-area. But they're actually only generated on the egress of the interface of the ABR. So technically speaking, they're being generated into the area that the ABR is already a member of, if you will. All right, but we do define these as inter-area LSAs because they do represent routes that come from other areas. Okay? I'm going to skip type 4 for now, and I'll leave a space down here for type 4, and I'm going to go into my type 5 LSAs. All right? A type 5 LSA is called an AS external LSA. And I'm going to describe what they are first, and then we'll go ahead and do our discovery on our topology here. But a type 5 LSA, these LSAs are only generated by one special router. Not a special router, but a router that's doing redistribution. That's called an ASBR. The type 5 LSAs represent all of the external routes that are being redistributed into OSPF. These type 5 LSAs are only generated, let me actually put this down. Hold on one second, I lost my mouse here. The heck did it go? Oh, there it is. Okay. These are going to be generated by ASBRs in normal areas. There is another type of LSA called the type 7 LSA which are actually generated by ASBRs that are in non-normal areas, what we call special area types. So we'll talk about that later on. These are generated by ASBRs in normal areas. By the way, those ASBRs can be in really any area. It doesn't matter if it's area 0. We can attach ASBRs to area 0, area 2, area 1, as long as it's not a special area type. All right, the scope is inter-area, and they remain as type 5s across the ABR. So even though they start as type 5s, when they cross the area, 2 C's in there, when they cross the area border router, or boundary router, area border router, they stay type 5s. So router 4 in this case is redistributing routes from the internet. It's generating type 5 LSAs into the topology, into area 0. Well, those type 5 LSAs stay type 5 LSAs as they move into area 1 and area 2. All right? These actually show up, I forgot to put that over there too, I'll put that over there, in the routing table as either OE1 or OE2 routes. All right? And we'll talk about that. I don't know if we're going to get into that in this lesson. It just has to do with essentially how metrics are calculated for these external links. The default is OE2, which means the seed metric is the metric that the seed metric for the distributed routes, redistributed routes, is default sent in as 20. It's going to remain 20 no matter where you go within the autonomous system. So we'll see these as OE2 routes in router 2 and router 3. Later on, I'll teach you guys the difference between E1 and E2, and we'll talk a little bit about what the benefit of one is versus the other, and why I would potentially want to send routes in as an E1. In this case, it doesn't really matter because we only have one ABR, and we also only have one ASBR that's originating these routes. But they're going to show up in the routing table as OE1 or OE2. The scope I already mentioned is inter-area. By the way, we can summarize these routes on the ASBR, and I will actually demonstrate that in a minute here, but they still remain type 5 regardless. So even as they go, even though they're considered kind of summaries, they're not really type 3s. They're going to stay as type 5s even as they leave the area. Okay? I forgot to put over here in this side, show in the routing table, as OIA routes. So one of the things that you'll probably see on the written exam, guys, is you'll see maybe a snippet of a routing table, and they're going to want you to potentially try to infer what's happening in the topology based on your understanding of what types of routes exist. And they might ask you something like, who's the ASBR? Or is there an ASBR? Or, I mean, those would be pretty simple questions to answer. But based on your understanding of these type 5 route, or these different types of routes, how do they show up in the domain? All right. So we inject these type 5 LSAs by redistribution. All right. These type 5 LSAs will contain metric and cost information, pretty much like a type 3. We haven't talked about type 4 yet, but we will. But because this information is external from the routing domain, there's some additional information that's going to be included with these different types of LSAs. We'll take a look at that in the database in a second, but I want to point out a couple of things. Number one, there is an EBIT value. We already kind of saw the EBIT represents some sort of external indication. The EBIT specifically within the LSA is going to designate the external metric of the route. So we are not identifying the metric to get to the route. We're identifying the metric of that external route based on how it was redistributed into OSPF from the ASBR. This is going to be used for type 2 external routes. In type 1 external routes, we don't include this information. The actual EBIT is set to 0. So, and like I said, we'll talk about this in more detail later on. So then the metric that's calculated for those external routes ends up being the overall path metric that we have along the path to reach those particular destinations. I'll see if I can show you the difference here real quick. Okay? Two other things that might be included. Forwarding address. This is going to specify where the transit traffic should be sent. This could be done intentionally. Well, it's certainly done intentionally if we're advertising it normally, but we could set it to 0, where the forwarding address in that case is going to be essentially the router ID of the originating router. Actually, there's a couple of caveats when we get into our traffic engineering section. We'll talk about setting that forwarding address to quad zeros and what the effect of that would be on our routing. That's definitely a CCIE level topic. There might be a route tag that's applied as well. So if we're doing a redistribution, a lot of times we'll include a route tag, which is just a 32-bit field that allows me to identify that route individually. By default, that's not going to be set. Okay? Even if you're redistributing static routes or connected routes, those generate type 5 LSAs. They don't have to be routes that come from another autonomous system or another routing protocol. So let's investigate what these routes look like on router 2. If I do a show IP OSPF database, just looking at the summary of our database, we can see here our type 5 LSAs. By the way, these are our type 4s. We'll talk about that in a second. We can see our type 5 LSAs. The advertising router is always going to be the router ID of the originator of those links. Okay? And we can see that is there a route tag applied, and we'll drill down into these routes and see some of the other details. But these are my type 5 external LSAs. I never understood why Cisco, I mean, I guess I kind of understand, but it's kind of nice to see the type 5 next to that, right? Autonomous system external link states, those are type 5s. It'd be kind of nice to see maybe a type 4 next to this, and a type 3 next to that, and a type 2 next to that, and a type 1 next to that, because maybe be easier to kind of differentiate those things in the table. But anyway, type 5 LSA, let's see what those look like from in detail. All right. So the originating router or the advertising router is the router ID. This is the network ID of the prefix that's being redistributed. This is the prefix length or the subnet mask for that. All right, the metric type is coming in as 2. And notice they've made a note here. It's larger than any link state path, which would indicate that the metric for this particular route is not necessarily efficient. But because we're sending it in as a type 2, it doesn't really matter. All right, I'll get into that in more detail later on. This is the default seed metric for redistributed routes into OSPF, which is a cost of 20. The forwarding address is actually zeroed out here. That's definitely something that we'll spend some time talking about later on when we get into the traffic engineering section. All right. So what's interesting about this is that it describes the external link. The link state ID is the actual network ID of the external route. It describes the prefix. It describes the metric. And I guess to an extent, it also describes the router ID of the router that's originating the external route. But here's the problem. Router 2 doesn't know anything about router 4. Router 2 is in area 1. Router 4 is in area 0. So there's no type 1 LSAs that are being exchanged between router 2 and router 4. I'm learning information about an external prefix, but I don't have any information on how to reach router 4. So type 5 LSAs by themselves are really not very useful. from the perspective of other routers in other areas that are receiving these type 5 LSAs. Here's the other one, by the way, and so on. So before I get into that next part, which takes us back to type 4 LSAs, I'm going to go into router 4, and we're going to really quickly show you how we can summarize these type 5 LSAs into OSPF. Let me do a show run section router, and I just want to see how we're doing the redistribution, show you guys how we're doing the redistribution in this case. Most likely just a redistribute connected. Yep. So we're doing a redistribute connected, all the subnets based on the route map redis. Okay. So I'm going to come in here and do a similar thing in this case. Interface loopback 1, IP address 11.11.8.1.255.255.255.0. Interface loopback 2, we'll do this one as 9. And interface loopback 3, we'll do that one as 10. So I'm creating the similar subnets that I did on the other side. And if I do a show run pipe section router, pipe route map, and I'm probably going to have to look at an access list as well, we'll be able to see how we can include these routes as part of our access-list, as part of our redistribution process. Because right now these are just connected routes on the router itself. So I want to insert these routes into the OSPF process. So I'm just going to go ahead and add another access list line here. And we're just going to permit the 10 subnets, permit 11 subnets, 11.11.8.0, 0.0.3.255. So I'm doing a block of 4 starting at 8. Now, my first inclination, once I've applied this configuration, my first inclination is to make sure that the routes actually made it into OSPF. So I'm going to go ahead and take a look at there's a couple ways I can do it. I could do a show IP OSPF and, or show IP OSPF route, excuse me. And I should see those subnets in here. I don't. Let me do a show IP OSPF database self-originate. Okay, well, they're there. I'm not sure why they're not showing up here. Probably because they're connected subnets. Yeah, these are all my non-connected networks. So I might have to use some arguments to see the connected ones. But in any event, obviously in this case, I'm doing redistribution. Whenever you're doing redistribution, before you start going and troubleshooting those routes on other routers within the topology, you want to go ahead and make sure that you know that those routes are making their way into OSPF on this topology in this local router. Because if they're not going into the database locally, they're certainly not going to make it into the database of other routers. So I can definitely see that those routes exist here. And sure enough, if I go to router 2, I should see, let me just do the full summary here. I should see those routes coming in to router number 2. All right? And they're just coming in as type 5 LSAs. The reason why I created those is because I wanted to show you guys how we can summarize those routes into OSPF. It's a little bit different when you're doing it on an ASBR as opposed to an ABR. All right? Don't worry about the syntax right now. I'm just demonstrating this because it makes sense to kind of show you some things. We're going to have a whole lesson on summarization later on. All right, so router OSPF 1, and we use the summary address command in this case. We do not use the area range command because remember, the area range command allows us to identify what area summaries are coming, what area the routes are coming from that we're going to summarize. In this case, these routes are not coming from an area. They're coming from an external routing domain. So I'm going to do a summary address, and then I just specify the address, 11.11.8.0, put in my subnet mask, 255.255.252.0, and I've created a summary for those external routes. They're still going to come in as type 5s. And they're still going to show up as type 5s in the other routers. The only difference here is we're going to get the summary here. Now we are seeing the 9 and the 10. Those will eventually age out, but this is the summary. So if I do a show IP route OSPF, you can see here's my OE2 route. Those are the internet prefixes. Here's my OE2 route. It's being originated by router 1. It has a seed metric of 20, which is the default for OE2. So that's the difference between E1 and E2, is whether or not this seed metric is going to increment as I move across the autonomous, the OSPF autonomous system, or is it going to stay the same? And E2 routes, they will stay the same. Now I could go into router 4 if I wanted to be really creative, and I could actually change the metric type. This goes to what we were talking about in one of our very first lessons, which is route manipulation through the use of route maps. And I could come into route map redis permit 10, and I could say set metric dash type to type 1, right? I have a choice here, either type 1 or type 2. So I'm going to set it to type 1, and I can also even say set the metric, and I can specify the seed metric for that particular route. So let's say we're going to go ahead and send those in as 100. So section route map. OE1 routes are still considered type 5s. Don't get confused if somebody says they're coming in as type 1. You have to clarify, are you talking about OE1 or are you talking about type 1, right? LSA type 1. So now if I go to router 2 and I take a look at the route, you can see now that it's coming in as an external type 1, OE1, and the seed metric that we injected was 100, and we're now accumulating the path cost along the way for the additional links between router 4 and router 2. All right. Not really necessary in this particular case, but because we only really have one way to get to those routes, so having an incremental metric for those external routes doesn't really change anything. If I was injecting external routes, the same external routes from two different ASBRs in different areas of my domain, then I might choose to send them in as E1, because then I can allow shortest path routing for all the routes that want to reach those external networks. All right, so let me see if there's any notes I want to add for my type 5s. I will add one more thing. Actually, I'm going to add one more thing to this one here. Type 3s, well, I don't need to put that. This is the type 3 summary. Not allowed to enter and we'll talk about this later when we get into our special area types, not allowed to enter a totally stubby or totally not so stubby area. Okay? I'll defer the discussion of that when we get into our special area type discussion, but type 3 LSAs are not allowed to enter totally stubby or totally not so stubby areas. Type 5 LSAs are not allowed to enter any special area type. So if I have an area set up as a stub area, or I might as well put it stub / total stub / not so stubby area / totally not so stubby area, etc. Okay, so if I had area 2 configured as a stubby area, then the type 5s coming from R4 would stop at the area border router going into area 2. All right. All right. So far, so good. So let's talk about these crazy Type 4 LSAs. Type 4 LSAs can be very confusing. You know, if you look at them kind of without talking about some of the other external LSA types. Basically, you think of a Type 4 LSA as a Type 3 LSA, but instead of being generated by ABRs, they're generated from ASBRs. I'll explain what I mean in a second here. Okay? The Type 3 LSA, the reason why I say think of them as Type 3 LSAs is because they actually use the same format as a Type 3 LSA. But the difference is, and the differentiating factor, is that Type 4 link state IDs is the actual router ID of the ASBR, whereas if we're looking at a Type 3 LSA, it could have the link state ID of the network itself. All right? The only reason that we have Type 4 LSAs is for ASBR reachability. All right? So I might need more space than what I have here, but let's give it a shot. Type 4 LSAs. You can see from router 4's perspective, actually go to router 2, show IP OSPF database, that these Type 4 LSAs show up as Summary Autonomous System Boundary Link State LSAs. So I usually just call them Summary ASB LSAs. Or Summary AS LSAs. All right. And before I start making some notes here, let's go ahead and take a look at what these look like. ASB, sorry. All right. So first things first, these are considered to be inter-area LSAs, much for the same reason that a Type 3 would be considered an inter-area LSA, because the LSA represents another LSA that's generated by an ASBR. All right, we know that the Type 1 LSAs that are generated by an ASBR are going to have the E bit set, and they're going to have other bits set to indicate that this is an autonomous system boundary router. The router 1 is receiving that information and then making receiving the information and then making a decision based on that. I was just reading the chat here from, let me see what it says here. Sorry about that. Can you describe more about, here, let me pull this over here. Can you describe more about OE1 and OE2? I know one beats the other, so it's good for failover, but what is it? Okay, I will, Mike. Give me a minute, and I'll go back and describe what I mean by that. One of the things, and what Mike's referring to here, is one of the things about different types of routes in OSPF, and we'll talk about this in more detail later on as well, is that OSPF makes decisions on what routes to choose based on the types of routes that they are. And there's a hierarchy of what routes I will choose over other routes. For example, I'm always going to choose intra-area routes over inter-area routes. So I'm going to if I receive a route to a destination, or I know a prefix, receiving an information in my database about a particular destination through Type 1s, I will use that route over a Type 3. Okay. This also applies to external routes as well. Internal routes are going to be preferred over external routes. What I want to describe, though, is, well, what Mike is asking is, why would I choose an OE1 route over an OE2 route? Why would I choose that, and so on? So I'm going to describe that in a little bit here, Mike. Okay, let me just wrap up this discussion about type 4, and then we'll get into that in a little bit. All right. So type 4 LSAs, they're generated by an ABR, and really the easiest way to describe it, generated by an ABR that is attached to an area that includes an ASBR. And these are advertised out of the area that includes the ASBR, which means that in this case, area 0 has an ASBR, right? And that means that my type 4 LSAs are going to be sent into area 1 and into area 2. Hold on, all right. So we'll take a look at what those look like in our database, but essentially these LSAs are used to describe reachability to the ASBR in the other areas that are not attached to the ASBR. Remember I talked about how router 2 knows about the external routes, but it doesn't necessarily know about how to get to the ASBR. And that's essentially what these that's what these this type 4 LSAs are representing. Okay, let me see here. Notes, summaries. No, we don't need that. Scope. I guess we could define the scope as inter area scope. Type 4s will be sent into other areas outside of the area that the type 5s are originating from. Type 4s, well, I don't need to put this, but it kind of makes sense. If I've got a special area type and type 5s are not allowed into that area, then it kind of makes sense that the corresponding type 4s would not also be allowed into that area. So any area that type 5s are not allowed to go into, you can assume that the type 4s are not going to be able to go into as well. Okay? These actually don't show up in the routing table as any particular type of route because they don't represent routes. They represent reachability information to the ASBR. All right? So let's go into our router 2 and see if we can drill down into these type 4s. Summary ASB, show IP OSPF database. And I'm looking for summary ASB, which is, interestingly enough, listed as ASBR summary. All right. So the link state ID is the autonomous system boundary router ID. And the router that I need to go to get essentially type 1 reachability to that router is router 1. So router 1 is basically saying, you know what, come to me if you need to reach router 4.4.4.4. So you can see it doesn't actually represent a prefix. There is a metric associated to it, just like a type 3 LSA. Like I said, it's going to have some sort of metric associated to it. But I'm basically saying, look, router 2, if you want to be able to get to router 4, which is an ASBR, come to me. Okay? So, all that being said, this router here, I'm just going to put some notes on the diagram here. This router here is an ASBR. So it's going to be generating type 1s and actually it's an ASBR and a DR, isn't it? So it's going to be generating LSA type 1s, type 2s, and type 5s. Okay? And this router here is an ABR. trying to think how I want to put this in here so it's easy to read later on. All right. I think I'll use different colors here. Yeah, that's what I'll do. I'll kind of differentiate with the colors here. So on this side, on the ABR, the red ones are going to be type 3s, and we're still going to advertise the type 5s from router 4. Okay? And let's do our little arrow there. This is going to get a little confusing, but I think we can do it. All right. And then also we'll see the same thing down in this area. Oops, I also forgot. Let me do that again. Because I forgot my type 4s. The ABR is going to actually generate Lsa type 3s, type 4s, and type 5s into that area to represent the ASBR in the other area. And on this router here, actually out this interface, we'll do the same thing. Lsa type 3s, type 4s, and type 5s going into this area. All right. So conversely, coming from router 2, obviously router 2 is going to be generating its own LSAs. Let's go with dark blue in this case. So router 2 is going to be, it's just kind of an internal or normal router, internal router. And I'm not sure if it's the DR or not, but let's assume it is for whatever reason. Yeah, it probably should be. It's got a higher loopback for that link. So it is an internal router / DR. So it's going to be generating Lsa type 1s and 2s. And those are going to be sent out that link. And the same thing with on this side, because we're in ABR here, we're going to be generating type 3s in that direction based on those routes that are coming in from the DR or from router 2. You guys get what I'm doing here, right? It's kind of, I'm trying to kind of show you how these routes get represented as I move from one area to another, if that kind of makes sense. All right. And we'll use, let's do purple. Yeah, I guess purple will work. All right. So this router here, because also it is, it's most likely, it's an internal router. And it's also a DR, most likely. We'll just assume it is. It's going to be doing the same thing. Lsa types 1 and type 2. And those will move over to, they'll leave this ABR here as Lsa type 3. Am I missing anything? I think I got everything.
What about on a type 7?
Oh yeah, no, I meant just right now based on what we see in the topology. Did I miss any? Oh well, yeah, of course router 1 is going to be generating its own type 1s as well, right? Router 1 is, let's just do router 1 as black. So router 1 is an internal router to all of these areas. So as an internal router to this area, it's going to be generating Lsa type 1 into that area, into that area, and into that area. So I guess we could put that on there. We're definitely going to talk about type 7. No. All right. And I'm just going to put a black arrow. I don't want to keep putting more stuff on here, so I'm just going to put a black arrow here. So our type 1s are kind of going into each of these areas here. All right. And because router 1 is not an ABR, it's not going to generate type 2s. Does that make sense? So we're sending in our type 1s in each of these areas. All right. Keep doing that. Don't know why. All right. So that's kind of the flow of our link state advertisements. Type 3s are being generated based on the 1s and 2s that are coming from router 4. Type 3s are also being generated from the 1s and 2s, or the ones that are coming from router 2 and router 3, and so on. All right. Now we do have another type. It is called a type 7 LSA. All right. So type 7 LSAs, let me put my notes here. They're essentially exactly the same as type 5s. All right, let me see if I can actually generate some type 7 LSAs in our topology here. Let's go into router 3. Oops. And actually, we need to go into router 1 first. So type 7 LSAs are link state advertisements that are advertised by an ASBR that is a part of a special area type. And we're going to get into later on what special area type configurations look like and so on. But in order for me to actually generate type 7s, I need to go ahead and create a special area type. And on top of that, I need to make one of those routers in that area redistribute routes into that special area. So if I do a show run pipe section OSPF, I can see the configuration for area 2. We're going to go ahead and make area 2 a special area type. So config router OSPF 1, and I'm going to type in area 2 NSSA. I'm just going to make it a not so stubby area. Not so stubby means that type 3s are allowed in, but type 5s are not allowed in. External routes are never allowed into a special area type. Notice I lost my adjacency here because one of the flags that is set in the context of OSPF is the area the stub flag. Okay, so let me make a bit of a change here because now this is an NSSA. We now we'll essentially see our type 5s are going to be suppressed, and we're not going to see type 5s and type 4s in this particular area anymore. So only type 3s are going to be allowed and a default route. I'll get into the details of that later on, but we're no longer going to send the 4s and 5s into the area because it's an NSSA. So let me go into router 3 and router OSPF 1 and area 3 or area 2 NSSA. All right, so now I should get my adjacency back, and I've essentially configured this area as a special area type. If I do a show IP route, you will notice that I've lost my external routes and I only have my type 3s coming in. NSSA is the only special area type, we'll see this later on, that doesn't automatically inject a default route. Stub areas, totally stubby areas, and totally not so stubby areas, the ABR will actually send in a default route into the area automatically. This is the only time when these default routes are not injected if it's an NSSA. So let's go ahead and set up this guy as an ASBR, show IP route, show IP interface brief. And let's just create a loopback, config T, interface loopback 1, IP address 12.12.8.0, 8.1, 255, 255, 255.0. And I'm going to go into router OSPF, and I'm just going to do redistribute static subnets. So I'm just sending that route in, redistribute static, dang it. Router OSPF1, no redistribute static, redistribute connected subnets. So I'm sending in that loopback now into OSPF. Now if I do a show IP OSPF database, you will see in this database that we now have a type 7 LSA in the area that's a special area type. Type 7 LSAs are identical to type 5 LSAs. The only difference is they are external routes that are being generated by an ASBR that is attached to a special area type. Could either be not so stubby or totally not so stubby. Okay? So these type 7 LSAs pretty much look exactly like type 5s, but there's a significant difference. So what I was saying before my batteries died is that the ASBR is sending in these type 7 LSAs, which are just regular external LSAs that represent the external routes. At the area border router, I'm still going to send in type 4s for reachability information to the ASBR in that special area type. But here's the kicker. Those type 7s are converted to type 5s at the area border router. So unlike, let me make a little bit more space here. Those type 7s become type 5s. So they essentially get treated the same way. They're treated as external LSAs, but once I cross the boundary, those type 7s become type 5s. All right, and we're also going to be sending in those type 5s up here as well into this area. All right, in fact, we'll actually be sending in, and I will add this here. The ABR is going to send in LSA type 4s and type 5s here that represent those same routes that come from router 3. Does that make sense? All right. So there's really no difference between, like I said, a type 7 and a type 5. It's just simply a matter of you know, whether or not those they're going to show up as type 7s or type 5s, either in the area that's a special area type or outside of the area once they cross the area border router. All right, and I did forget actually, because I should still see some type 3s as well. I knew I was missing one. ABR is going to send in LSA type 3s, type 4s, and type 5, representing the purple ones that are coming from area 2. Because we're still going to summarize, just because we have a special area type does not mean we restrict what leaves the area. We're only restricting what comes into the area. All right. So we've got our blue type 3s that represent router 2. We've got our on the area border router. We've got our purple 3s, 4s, and 5s that represent the reachability to the ASBR that's now in area 2, and then the type 7s, which become type 5s. Okay? So I was thinking about what Mike was talking about earlier with regard to why would I select one type of route over another? For example, if I'm learning about the same route prefix from two different ASBRs, and one ASBR is sending those routes in as a type OE1, and the other one is sending it in as an OE2, which one would I prefer? Okay, and actually I was thinking about, in one of my other lessons, going through the process of describing all of that in detail. So I'm going to table that discussion for right now, but I do want to say this. And I'm going to draw some diagrams later on that describe some potential suboptimal routing problems that we could potentially have based on the fact that we choose certain types of routes over others. But I think I'm going to table that discussion until we get to our traffic engineering section. Okay? But I will say this. O routes are always going to be preferred over OIA routes. O routes and OAA routes are always going to be preferred over external routes. And then finally, within the realm of external, OE1 are going to be preferred over OE2. I did need to add a couple of things here, and I totally forgot that. I was going to put in my Type 7 stuff here. Type 7 LSAs, as you can see from the database here, these are referred to as AS external links, but they're just listed simply as Type 7 AS external. I'll go ahead and just call that AS external, which is unique from Type 5s because Type 5s, well, they're also called AS external, but they're indicated with a Type 5 next to them as opposed to a Type 7. And I think I just answered my question that I had before is why do I have Type 5 versus Type 7? All right. These are generated by ASBRs in special area types, and specifically an NSSA or totally NSSA. All right. What else? The routing. This is interesting. The routing table, they are going to show up. Let me go over to router 4, show IP route. They're going to show up as external here when they become Type 5s. But if I go to router 1, they show up as N routes. N stands for not so stubby. So in the area and on the area border router, the Type 7s will show up as N routes, but once they become Type 5s, they'll revert back to E routes. So you might see that from time to time. So they're going to show up as ON1 or ON2. And again, it means the same thing, right? One is whether or not the metric is going to remain the same or whether or not the metric is going to change as I move through the topology. Okay? We can still summarize. We can summarize just like a normal ASBR. And it would actually be the same syntax, and they would still show up as Type 7s and they get converted to Type 5s. And these are also not allowed to enter other special area types, right? Only the originating area are they allowed. Okay? That's a good point because Type 7s, I mean, if you think about the whole point of a special area type is that it's not supposed to allow external LSAs, but in this particular case, they're allowed in this area because we made it, quote unquote, not so stubby, if you will. Okay? So let me save this file, and we'll save this in our Google Drive. All right, do we have any questions, guys? I know it's a lot of information, but hopefully it kind of gave you an idea of where you might see these different LSA types. There's certainly other LSA types that we still need to take a look at, specifically the ones that we would see for IPv6, especially because in IPv6 they have similar LSA types, but they had to develop an LSA for link local information. They had to develop an LSA for multicast information and so on. So we do see that in those other, in IPv6. So let's just do LSA examples. Okay. All right. Do you guys have any questions? Good to go? Can you guys hear me? Did I lose my audio?
I heard you. Yeah, no question.
Okay. I mean, did you guys, did you pick up anything in that? Is that, I mean, it's a little bit of review from what we did in CCNP.
I did. I think it's going to take some practice for me just to, you know, to understand like the LSA 5s and 7s. I definitely get that. I think it's just going to take some practice to be able to look at it very quickly and know what's what.
Right, right. Yeah, that's the part about this, because it can be really confusing if, especially as the topology grows, and of course in the CCIE the topology is going to be huge, so is the database, right? And having to filter through that information is going to be a lot more challenging than when you just have 4 routers, right? So, but I will continue. As we go through the other lessons, I will continue to point out the database stuff. I'll continue to point out the different LSAs. So hopefully by the time we go through multiple iterations of the discussions, it'll kind of sink in a little bit more, because we're going to see these LSA types for every single exercise that we do. So I'll make it a point to continue to kind of point out, okay, this is why we see these LSAs, this is why we see these, this is why these are filtered, and so on. So that's good feedback, because I would not have normally thought to do that, but I will definitely do that just to kind of reiterate for you guys, okay?
Appreciate it.
All right.
Hey, Scott.
Yes, sir.
This is Ken. Can you go back over just real quickly the OE1 versus OE2, where you said O routes are preferred over IA routes?
Yes.
You mentioned 2 other.
There's an order of preference. It kind of has to do with like BGP, where external routes are going to be preferred over internal routes within BGP for various reasons, right? Internal routes should never be used in BGP because we should be using some sort of IGP to route to our internal networks. Well, OSPF has a certain hierarchy as well, and I do want to get into it in a lot more detail. But in this topology, it doesn't really apply, because in order for us to choose one path over another path, we would actually have to, let me see if I can come up with a diagram here that kind of describes this. I'll delete that, this one right here. I've already saved it. I'll just make sure not to save again. All right, so let's say, I'm going to try and think of this off the top of my head, but let's say I've got R1 here. And R1 has a link to R2. And we have another link here to R3. And R2 is an ABR. I might have to edit this. I'm kind of doing this off the top of my head. And R3 has a link to R4 as well. This is area 0. And this is area... Yeah, I could do that. 1. Oops. No, I don't want to do that. I got to include network X. This is area 1. Okay? Do it one more time. I'm not doing a very good job of drawing this circle here. All right, so that's area 1. All right? So router 2 and router 3 are area border routers. And they're both learning about network X from router 4. All right. So if we put some path costs in here, let's say this guy has a path cost of 10, and this is where I might have to get a little creative. This guy has a path cost of 15. this pi has a path cost of 5. Let me think, hold on. I want it to go that way. Which one do I want being more preferred? Hold on, I'm thinking, hold on. You guys are challenging me with this after all this hard work. Let me just walk through a scenario. Maybe I'll guess lucky here. So let's say, let me just make these the same for now. All right, I can modify it. Once you guys understand what I'm trying to describe here, you might actually understand what it is that I'm trying to describe here. So if I was to take this path here, that would be a total path cost 10, 15, 20 of 20, okay? And if I was to take this path here, that would be a total path cost of 10, 15, 20, 25. I might have gotten lucky on this one, okay? So in this particular case, I'm going to erase those lines, but you guys get the idea. In this particular case, the top path would actually be more preferred over the bottom path. All right? And actually, let's just get rid of this link right here, okay? Because I don't think we need that to describe this concept. All right? So I have two ways essentially of getting to network X. But this path here, thinking.